Work holding is absolutely critical to any CNC operation. I might be stating the obvious here, but when you're cutting that stock material, it's got to not move. So keeping the stock material secure is essential for good reliability and good accuracy. In this series, we'll cover some common approaches to work holding with SmartBench. We'll cover what makes a good spoil board, what makes a good stock material, some positioning techniques, some fastening techniques, and finally we'll do some examples which cover some common scenarios. Before we get into each area, let's just define the terms. So a typical assembly will use stock material. Here we've got some plywood. And underneath that, we'll use a spoil board. And the main reason for using a spoil board is such that when the cutter punches through the stock material, it's got somewhere to go without damaging your SmartBench. So the spoil board is just a sacrificial support layer. So what makes a good spoil board? Well, before we go there, let's recap on what the spoil board has to do. First of all, it protects SmartBench from damage when the cutter breaks through your stock material. Secondly, it can act as a large format work holding surface, which can easily be removed when SmartBench isn't in use. Thirdly, it does actually improve the surface finish to the bottom side of your stock material. By being in direct contact with the stock material, it offers support to the bottom surface of the stock as the cutter breaks through. Here I'm using a 9mm MDF board with melamine facing, but it's not the only option. As long as you stick to a few basic rules, you'll be fine. So things that are important: it needs to be rigid, it needs to be flat, it needs to be big enough, obviously, to cover the area that you're cutting, and it needs to be smooth. Let's talk a little bit about why smooth is so important. Smooth on the top surface is important such that when you put your stock material down on the spoil board, it doesn't artificially lift up the spoil board in high spot areas. And that means that you're keeping your stock material as flat as possible. It's okay to have track marks from previous cuts in the top surface of your spoil board. But if you do, just make sure that there's no bits of swarf that are kicking up, which might actually foul your stock material. And smooth on the bottom surface is really important because the lower beam contacts the bottom surface of your spoil board. When you use beam clamping to hold onto your work materials, that applies pressure from the bottom surface of the spoil board down onto the rollers on the lower beam. So if you've got any track marks or areas of inconsistency on that underside, that's going to cause resistance in the lower beam as it moves along the y-axis. And if it's too much, that could cause the y-axis to stall or start moving your material around. So in summary, have as smooth a spoil board as you can. It's okay to have track marks on the top surface, but not on the bottom surface. One important thing to note about your spoil board is that it can actually affect the accuracy in the Z-axis. If you've decided to go with a very thick spoil board, be aware that it will also be very rigid. And whilst it might start off as flat, if there's any change in your environment, that might cause the board to warp. And because SmartBench references the top surface of your assembly, that can manifest itself as inaccuracy in the Z-axis. If Z-axis accuracy is important on the large format, you might want to consider using a thinner spoil board. Now, while that's going to sag at the corners, you'll notice that the lower beam is actually going to support and level that out as it moves across the length of the job. So how about the stock material? What makes for good stock material? Well, clearly it needs to be large enough for you to be able to do the job and for you to be able to get good work holding. And your stock also needs to be flat. Being flat is good. It's going to help you with the precision. And also, it's going to reduce the risk of your cutout part popping out mid-job. Let's talk a bit about positioning the spoil board. It's good practice to have the spoil board in the middle of your machine and running parallel to that Y-bench. So to do that, we're going to be using the side of the bench as a reference, a spoil board with a straight edge, and a tape measure. All I'm going to do is take my tape measure, insert it underneath the boards till it hits the side of the Y-bench, and just note what the value is at this end. Okay, I've got my distance at this end. I'm just going to check the other end and see if that's the same. It's pretty similar. I'm just going to adjust the spoil board over a little bit more to even it up. Yep, that's the same now. And I'm just going to check this end as a final check. Yeah, that's bang on. Ready for the next stage. Next, we need to align the stock material. Now, there's a couple of different cases here. So we'll cover aligning a large sheet, and then we'll look at how do you align a smaller piece. The large sheet is probably the easiest one to talk about because we're simply just going to load that onto the spoil boards and make sure they're flush with each other, and then just do a final measurement check to make sure that it's all nice and parallel. For smaller pieces, we've got a few different options. Option 1, since we've already aligned our spoil board, we can reference from that flat edge of the spoil board. The process is the same as aligning a large sheet. Take measurements at both ends until the values are the same. Option 2, if you need better precision, then you can actually run the Z head up along the length of the stock and using a visual reference, make adjustments as necessary. In this case, we've got the laser datum, so we'll be using that. But if you don't have a laser datum, then you can use the center of your tool instead. And a third option, if you're not using a spoil board, for example, if you were just working on the top surface of your material, then you can just reference directly off the Y-bench itself. Let's talk about some principles behind locking large sheets to SmartBench. Now, while the beam does a good job of constraining the materials in the Z-axis, we need to make sure that those materials don't shift in the XY plane. There's a few methods to do this. Let's talk about clamping first. That's actually one of the quickest ones that we'll use. On the clamps, there's a couple of different options. You've got your speed clamps and you've got your G clamps. We tend to use the speed clamps because they're efficient and they do the job well. If you're using G clamps, they work too, but be aware that they've got a lot of mechanical advantage behind them and you need to be careful about where you use them. If we take this large format spoil board as an example, we can clamp using a speed clamp from the top surface down to the wheel tracks, or from the top surface to the underside of the end plate of the bench, or from the edge of the sheet to the underside of the leg hinge plates. If you're using G clamps, you should never tighten them onto the wheel tracks on the bottom side of the Y-bench. That's because there's so much mechanical advantage in a G clamp that you can actually deform the wheel track. If you did want to use a G clamp, it's absolutely fine to use them on the leg hinge plates, for example, which are going to take the load. We've just talked about clamping techniques at the home end of the bench, and it's worth mentioning that you can also use the far end of the bench with exactly the same techniques. As an alternative to clamping, we can also fix our sheet material to SmartBench by using wood screws. When using wood screws, we would be screwing into the sacrificial clamp panels on the Y-bench itself. Because I'm screwing through an MDF spoil board in this case, I'm actually going to drill a pilot hole, and that's just so that I don't deform the flatness of the top surface of the spoil board. And I'm also going to make sure that the screw head sits just below that top surface of the spoil board so it doesn't foul my stock material. Worth mentioning, if you're going to be routing through your stock material and into the spoil boards, just make sure you don't put a screw on the cut path. When you're fixing smaller stock pieces, your options are a little bit more limited because the spoil board can prevent you getting clamps in. Two options that do work well though are wood screws or double-sided tape. Again, with screwing, we need to make sure that the top surface of the screw doesn't foul on the machine, and also the position of the screw isn't in the way of a cut path. Using double-sided tape can actually be a good alternative to using screws. It just takes a bit of the stress out of it because it doesn't really matter where you position your tape. If the cutter goes through the tape, it's not going to damage the cutter. Apply the tape to the bottom of your stock material, peel off the backing, then place the stock material onto the spoil board. We've talked about positioning and fastening our sheet materials to SmartBench, and now we need to talk a little bit about supporting the beam. You'll notice on both the lower beam and the upper beam there are rollers. So first of all, it's important to make sure that those rollers are in the right position. In this case, we've got our spoil board, but the edge of the spoil board isn't actually over some of the rollers on the lower beam. So we've got two options here. We can either move that spoil board over the rollers, but if that exposes rollers on the other end, we can simply adjust slackening off the clamping bolt and sliding the rollers into the position they need to be. The upper beam also has bearings, and these bearings contact the top surface of your stock. So it's important to make sure that they're in the right position. Now you might not know this, but those bearings actually slide up and down the length of the x-axis so that you can position them to give the most support. What we're doing here is we're maximizing the stability of the beam during the cut. This point gets really useful when you're dealing with small stock material. Because we can slide the bearings, that means that we can position lots of bearings over the stock material and offer the upper beam as much support as possible. Now I'm happy that all my wheels are in position. I'm going to position the Z head over the job before I do my final clamp. That means that the weight of the upper beam is directly over the job, offering an even pressure before I set that final clamp position. Not only does this ensure that all the wheels are touching the material, it also ensures that the upper beam is parallel to the top surface of the stock material. Now I've set that upper beam to be parallel to the top surface of the stock. I move the Z head out of the way and I do a quick check just to make sure that these bearings are all evenly contacting my stock. One final thing to note is that your stock needs to be longer than the job, particularly in the y-axis. You need to have at least 70 millimeters of clearance at either end of the stock so that the stock offers support to the bearings in the upper beam across the full range of movement. Just to illustrate this, I've marked on a 70 millimeter clearance for my stock, which the job will operate within. So you can see here from this illustration, as long as the cutter stays within the 70 millimeter clearance, the bearings from the upper beam never leave the top surface of the stock. If you're in a scenario where you don't have the extra 70 millimeter clearance in your stock, then you can do things like putting runners along the side of your stock of equal or slightly greater thickness, and then repositioning the bearings to sit just on the runners. Alternatively, if you don't have any runners, you could also use another piece of material of the same thickness and just push that up to the edge of your stock. Bear in mind there will be a bit of a join, but it will give you a bit more support if needed. We've looked at some basic work holding techniques with SmartBench, but bear in mind that SmartBench is versatile and adaptable to suit your individual application's needs. Let's now look at two examples of common setups which cover both large and small workpiece holding. In this first example, we'll look at how we set up using a large format piece of material. For our spoil board, I've chosen our 9mm MDF. It's melamine faced. It does have track marks on the top, but I've checked for high spots. And it's nice and smooth on the underside, so the beam won't see any resistance. And there is our 12mm plywood going on top of our spoilboard. I'm going to bring it into flush with the spoilboard. Before I do any alignment, I want to make sure that my assembly is in the middle of SmartBench such that the material is over the rollers on the lower beam at both ends. I can see here that the material's over the rollers here, but I can see rollers exposed over here. So I'm going to move the assembly slightly this way to make sure that the material is fully supported. Yep, I can see that all the rollers on the lower beam are underneath the material in this setup. While I'm here, I'm also going to check that the bearings in the upper beam are evenly distributed so that when I drop that upper beam down, we've got a good pressure distribution. And now I'm going to take my tape measure and just make sure that the assembly is parallel with that Y bench. Just pushing the tape measure up to the bench, taking a measurement, 5.5. Just needs moving over a little bit. And then a final check. Yep, that's nice and parallel. Now I'm ready to fix our sheets to SmartBench. I'm going to be using our speed clamps here, and I'm going to be fixing them onto the wheel tracks. Start by doing it at the far end, and I'll clamp at the home end as well in the same manner, just to give as much purchase on those sheets as possible to stop them moving around in the XY plane. It's worth noting that I have homed already, so I'm quite happy to put my speed clamps on now. If I hadn't homed, that's okay, but I would need to remember to take these off during the homing procedure so I don't foul on the X-beam. Also, it's worth noting that I'm happy using clamps in this situation because I'm not working in the 70mm clearance zone that's needed at the end of the stock. If I was going to be working to the edge of the stock, then I wouldn't use clamps because they would foul on the beam. And in that situation, I would need to be using screws to avoid any collisions. Now that I've got my material positioned and fixed, it's time to clamp the beam. To do this, I'm going to walk the Z head into the middle. That means that when I drop the upper beam down onto the material, there's an even pressure. It's not biased to one side. I've checked that the beam is evenly seated. And now I do the clamps up. Now it's important to note when I'm clamping, I'm not putting my weight on the end of the beam, which could distort the pressure. I'm just letting the weight of the Z head in the middle of the beam do the job. And then when I close on the clamp, I'm only putting force on the handle. And there we have it. Large format sheet is now good to go. In our second example, we'll look at holding onto a smaller offcut. And in this case, again, we'll be using another 12mm piece of plywood. So same spoilboard again. This is our 9mm MDF with melamine faced, tracks on the top, but no high spots, smooth on the bottom. I'm just going to position that, make sure it's in the middle of the bench. Over all of my lower beam rollers. That's covered, and now I need to align, make sure that it's parallel to the bench. See, it's a little bit out here. 5, it's good. Bang on. I'm going to position clamps at both ends of my spoil board to give as much purchase as possible. I've already homed, but if I hadn't, then I just make sure that I home first to make sure that the clamps don't get in the way of that process. And now it's time to position our offcut onto the spoil board. Because I've aligned my spoil board, I know that that's parallel, so I'm actually going to use an edge of this offcut relative to the edge of the spoil board to bring it into rough alignment. I'm happy with that, and I know that it's positioned over the plywood clamping panels on the Y-bench, and I'm actually going to screw the whole assembly down together. When I'm screwing through all of the woods, I want to make sure that I reach the clamp panel and that the screw doesn't go through the aluminium extrusions of the Y-bench. An easy way to check to find out where your cross beams are on the Y-bench when you've got material in the way is just have a look underneath that spoil board and you'll see bolt holes wherever there's a cross beam. Once I'm happy with the position of my material, I'll put in some pilot holes into this material and then I'll screw it down. Now I've got my pilot holes in, time to put the screws in. Material's all fixed. Now it's time to do that beam clamping. Because the beam's low, I'm going to lift the beam up to start with so that I can position the beam over the stock. Before I drop the beam, I want to position my rollers in the right place. To do that, I'm going to just take the Z head out of the way and get all the rollers that I need. Spread her out around the stock. With the rollers in the right place, I'm going to move the Z head over the stock so that I can evenly sight the beam onto the stock. I'm checking that all the rollers are on even contact. That looks good. The beam is parallel. And now I'm going to lock off the beam again. I am not pushing down on the beam as I do this. I'm only applying force to the lever of the lock. Good to go. So there's two really common examples for work holding using SmartBench. Honestly though, work holding is a never-ending subject. I've seen some fantastic examples of how you hold your stock material to SmartBench. Instances of using hot glue, super glue and masking tape. If you have any good experiences that you'd like to share with us, please feel free to leave them in the comments below. And no doubt we'll be adding plenty more videos on this topic in the future. Thanks for watching. See you in the next one.